The total cost in dollars of renting a sailboat for n days is given by the equation C equals 120 plus 60n. If the total cost was $360, for how many days was the sailboat rented? Alright, in our equation, C represents the total cost and n represents days. So we could actually rewrite this equation using these words. So they tell us that C equals 120 plus 60n, and we could replace C with just the words total cost, and n we can replace with days. So we can just multiply by days. And the question's asking if the total cost was 360, how many days was the sailboat rented? So our equation has two variables, days and total cost. If we know how many days that the sailboat's rented, for example, if the number of days was 2, then we could solve for the total cost. Similarly, if we knew the total cost, say $150, we'd be able to solve for the days. So that's the idea this question's working with. They tell us that the total cost is 360, so we can write 360 on the left side for our total cost. And then we just have days in the equation, and we can solve for that. So we want to get days by itself, so we can start off by subtracting 120 on both sides. On the left side, 360 minus 120 would give us 240. And on the right side, our 120s cancel, and we're left with 60 times our number of days. So how do we get days by itself? We have 60 times days, so we have multiplication, and we undo that with division. So we divide both sides by 60. On the left side, 240 divided by 60 gives us 4. And on the right side, our 60s cancel, leaving us with days. So now we know that if the total cost were 360, that means that the sailboat was rented for 4 days. And looking at our options, that's option B. What is the y-intercept of the graph of 4x plus 2y equals 12? So we could rewrite this equation as y equals mx plus b, and that would help us find the y-intercept. However, there's a quicker way. Let's think about what the y-intercept is. So the y-intercept is where the line crosses the y-axis. So we have our x-axis here and our y up here. And our y-intercept is this point. And the important thing to notice is that for the y-intercept, the x-coordinate is always 0. So we would label this point 0, comma, and then some other number. Let's say maybe 4. And you can test this with any other line. Wherever the line crosses the y-axis, the x-coordinate is always going to be 0. And then the y-coordinate would be some number, let's say -3 in this case. So when the question asks, what is the y-intercept? It's asking, what is the point where x equals 0? So we can actually plug in 0 for x and find what our y value would be. So let's do that. We just plug in 0 for x. And now we just need to solve for y. On the left side, 4 times 0 is just 0, so that disappears. And then we have 2y equals 12. We'll divide both sides by 2, and we get y equals 6. So now we know that the point x equals 0, y equals 6 is on this line. And looking at our picture, it would be somewhere up here, 0, 6. And for this question, it doesn't matter what the slope of the line is. All we needed to find out is where it crosses the y-axis. Again, we could have written our equation as y equals mx plus b. So let's go ahead and do that. We want to keep our y on the left side, so let's subtract 4x. On the left side, our 4x's cancel, so we're left with 2y, and on the right side, 12 minus 4x is the same as -4x plus 12, and then we want to divide both sides by 2. On the left side, our 2's cancel, So we get y, and on the right side, we can split this fraction into two pieces, negative 4x over 2 plus 12 over 2. That leads to negative 4 divided by 2 gives us negative 2 times x, and then 12 divided by 2 gives us 6. So this equation is in the form y equals mx plus b. Our b gives us the y-intercept, so this tells us that 0, 6 is our y-intercept. And that's the same answer we got above, but you might find that the first way was a little bit quicker. And looking at our answer choices, all of these are technically wrong. It's asking what is the y-intercept, and looking at our graph, the y-intercept is a point, and a point has an x and y coordinate. So each of our answer choices should have been an xy ordered pair, but assuming that they just wanted the y value, the answer would be C. Which best represents the graph of y equals 2x minus 2? So our equation is almost in the form y equals mx plus b. To make it match, we need to rewrite it as y equals 2x, and instead of minus 2, we add negative 2. Now you can see that everything matches. Our m's line up, our plus signs, and our b. So this tells us that our slope is 2, and our y-intercept is negative 2. More precisely, the y-intercept is the point 0, negative 2. Looking at our answer choices, we can already cross out b and d, because both of these have a y-intercept at 0, positive 2. Looking at a and c, both of these have a y-intercept at negative 2. However, our first graph has a positive slope, and the second graph has a negative slope. Since our equation has a positive slope of 2, our answer would be A. And you can always double check that the slope is actually 2. So let's zoom in on option A. Starting at our y-intercept, we rise 2, and we run 1. So our rise over run is 2 over 1, which equals 2. So we confirmed our slope is 2. Which equation best represents the graph above? And each of our options is in the form y equals mx plus b. So we want to figure out what our m and b are. And looking at our graph, where is it across the y-axis? At 0. So in this case, our b is 0. And now we need to find our slope. So we need to pick 2 points and then find our rise over run. So we rise 2 and we run 1. So our slope is 2 over 1, which equals 2. So plugging those values into our equation, we have y equals 2x plus 0. And so that 0, we can just remove that and write it as y equals 2x. And looking at our options, that would be option B. Which equation represents the line shown in the graph below? Each of our options is in the form y equals mx plus b. So we need to find our m and b. Looking at our graph, the line crosses the y-axis at 4. So our b is 4. And now we need to find our slope. Let's pick another point. Starting at the first point, we rise 2, and then we run 3. So our slope, which is rise over run, is 2 over 3. So now we can rewrite our equation as y equals 2/3 x plus 4. Looking at our options, That's option A. What is the x-intercept of the line defined by negative 2x plus 3y equals 12? So now we're talking about the x-intercept. So what is that? We said that our y-intercept is where the line crosses the y-axis. Well, our x-intercept is where the line crosses the x-axis. We said our y-intercept has an x-coordinate of 0, and then some number for the y-coordinate. Our x-intercept has some value for the x-coordinate, and then 0 for the y-coordinate. Again, you can draw any line and see this. For the second line, it crosses the x-axis here, so it has some x-coordinate, and we're not going up or down, so it has a y-coordinate of 0. So when our question asks us, what is the x-intercept? It's asking, what is the point where y equals 0? So we can just plug in 0 for y. And solve for x. On our left side, we have negative 2x. And then 3 times 0 is 0. So this piece disappears. And on the right side, we have 12. To get x by itself, we divide by negative 2 on both sides. On the left side, we just have our x. And on the right side, 12 divided by negative 2 gives us negative 6. So this line has an x-intercept at negative 6, 0. And again, the options are just giving this x-coordinate. So that would be option D. Which point lies on the line defined by 3x plus 6y equals 2? So as we've discussed, a line is made up of all the infinite number of points that make our equation true. So if one of our points here makes this equation true, it's on the line. So we just need to check each point until we find one that makes the equation true. And looking at our first two options, if you notice, each of these points has an x-coordinate of 0. So these points represent the y-intercept. So option A is telling us that 0, 2 is the y-intercept, and B says 0, 6 is the y-intercept. Well, we can quickly find from our equation what the y-intercept actually is. So the y-intercept occurs when x equals 0, so we can just plug that in. 3 times 0 plus 6y equals 2. 3 times 0 is just 0, so we have 6y equals 2. We divide both sides by 6, and we get y equals 1/3. So the y-intercept for our line is 0, 1/3. So looking at A and B, both of them are wrong. A line only crosses the y-axis one time, and we just found out that it crosses here. It doesn't cross at options A or B. So that's a bit of a shortcut to checking those first two options. You also could have plugged each of those points into our equation to see if they made the equation true, which they won't. So now we just have options C and D. So those are just random points. So let's plug them into our equation and see if they make the equation true. So our equation is 3x plus 6y equals 2. And option C has an x value of 1 and a y value of negative 1/6. So let's see if that pair makes the equation true. So we have 3 times 1 for x, and then 6 times negative 1/6. And we don't know if those values make the equation true, so we'll put a question mark above our equal sign. On the left side, 3 times 1 is 3. And if we think of 6 as 6 over 1, we just have two fractions that we're multiplying. So on top, we'll get 6 times negative 1, which is negative 6. And on bottom, 1 times 6 is 6. Again, we'll keep our question mark up there. We don't know if this equation is true. On the left side, we have 3 plus, and then negative 6 over 6 is negative 1. And on the left side, 3 plus negative 1 is the same as 3 minus 1, which is 2. And our left side does equal our right side, so we can remove that question mark. And now we know that option C makes the equation true, so it's on our line.